All right, so this is IE 422X, Group 1 with Christopher Checkman, Kelly Iwamoto, Jonas Scallon, Eric Sesterhan, and Callum White. This semester we worked with Syngenta on their seed counting process. Syngenta is based out of Basel, Switzerland, and they employ 28,000 people in 90 countries. They rank first in crop chemical production and third in seed and biotechnology sales. We work down at the Slater, Iowa location where they focus on seed testing. Here, seeds are counted, sorted, and then shipped to various locations across the country to be planted and later tested. And they also have fields around their facility in Slater where they do testing as well.
So some of the objectives that we were tasked with for their new machines were we wanted to increase their throughput, reduce the costs, improve their layouts, and improve the ergonomics. So with increasing their throughput, when we were working with the company, we found out that the current bottleneck was the seed sorting. So kind of figuring out the situation with the new machines and finding ways to reallocate the workers from their old machines to the seed sorting allowed us to increase their throughput. Reducing costs, finding the most optimal machine combination so that they are able to have the most significant gain. Third, improving their layout. So with the addition of the new machines, we wanted to keep in mind the safety of the employees as well as making sure that they have enough space to work. Lastly, we were focusing on that kind of went along with their layouts where making sure that their job is safe and also trying to keep their walking around to a minimum.
In order to achieve these objectives, we had to use various tools throughout our analysis. The first thing that we did is we went to the facility and just watched what was happening and understood the process as it was operating. And then from there, we're able to understand it and be able to take some time studies on the specific processes that we're interested in. Specifically, we're interested in time studies on the counting and the sorting process. Once we took those time studies, we then fit them in a jump to find the distribution that fit them best. And then we used that distribution that we got from the time studies within Simio, where we created a simulation to model the process of the seed counting process. Finally, we conducted studies within AutoCAD to find the optimal layout for all our combinations of different machines, and specifically for the current state machines and for the future state, which Chris and Callum will talk about.
So Syngenta has tasked us with finding the optimal number of new machines and old machines to increase their throughput. We did multiple tests for every combination and listed the top 2 options for each combination. For example, we found that five of the old machines and 5 of the new machines and 4 of the old machines and 5 of the new and 3 of the old resulted in the biggest throughput increase from 53% to 63%. You can also notice there's some negative increases. This means with some of the variables that we had, Syngenta was not allowed to hire more than 12 people. These would cause bottlenecks depending on the combination of new and old machines. We also have the number of employees that can be removed from this to still get that throughput increase. As you can see in the 4 of the new seed ones and 5 of the new seed machines, we could remove 1 to 2 employees.
Based off the results for the simulations, we studied the economic impact of 5 new machines and 4 old, and 5 new and 3 old machines. The procurement cost for the new seed counters were $75,000 each, and those were spread over a lifespan of 5 years. The labor savings returned results between $9,000 and $18,000 per year from the amount of employees that were able to be reallocated, and the increased revenue set between $17 million and $20 million per year. This came from the increased throughput, where 1 out of every 1,000 trials that was sent through was generating revenue of between $5 million and $50 million over a 5-year lifespan, leading to net returns between $17 and $20 million.